Alright, so we just spent some time going through and checking solutions of an inequality to see if they work. What we're going to talk about now in this video is how to find all of the solutions of a linear inequality. Just like a linear equation, the graph of a linear inequality in two variables is the graph of the solutions of the inequality. Remember, this is something that Mr. Harrison has talked about several times, trying to get you to understand that the graph of something is not just a pretty picture, it is a graph of the solutions. It shows you all the answers. So what we're going to do is kind of what this page talks about here, and I'm going to kind of go through it over on my paper over here. We're going to take a look at first solving this guy for y just like we would an equation. Basically, what we're going to do, is we're going to get this into slope-intercept form. So we're going to take the 2x here, and we're going to subtract it over to the other side. That's going to leave me negative 3y, and that's going to give me minus 2x on this side. Then we're going to divide by negative 3, just like we do with equations. But here is a major difference with inequalities. Notice you divided by a negative on both sides. So that means you have to flip this symbol around to a less than or equal to symbol. Negative 2 divided by negative 3 is going to be a positive 2/3. Negative 2 divided by negative 3 is another positive 2/3 x. If you switch that around, that is going to be your slope-intercept form, as we have talked about with equations. Excuse me. So the next thing that you're going to do is you are going to graph this basically just like you do an equation. You're going to graph the line, but you're going to have to make sure anytime there's no equal to sign right here, you do not make a solid line on the graph over here. Many of you probably remember doing this in Algebra 1. When you had just a less than symbol like this one does down here, you make a dashed line or a dotted line. So what we're going to do is we're going to begin here at 2/3, which is basically partially the way between 0 and 1. And then we're going to go up 2 full spaces over 3. Notice it's still in a partial area there, because if you start at 2/3 and you go up 2 over 3, your line is not going to be on some perfect points there. If you connect the dots for this line, you will see that you have a line going across the graph like this. Notice that from our solutions that we had earlier, 0, 0 is a solution. 2, negative 1 is a solution. Excuse me. And the point 2, 2 is also a solution. If you plot 0, 0, 2, negative 1, and 2, 2, you're going to see that all three of those points are on the line or below it. Notice your symbol over here is less than or equal to. This is where the same kind of thing that comes into play with our inequalities on a number line, where we do a solid dot or an open dot and then we shade, comes into play the exact same with this. We're going to have a solid line because the equal to tells me the points on the line are solutions. And we're going to shade below the line because the points below the line will also be solutions. Notice that the point 0, 1 is not a solution. 0, 1 is right here. It's kind of hard to see because of my graph being so small here. But 0, 1 is above the line. Again, the solutions are less than or equal to, on the line or below the line. Just make sure your shading is obvious. Make sure your line is obvious.